Welcome back. Let's do question 5. Consider the arithmetic sequence, which is given. We have 22, 25, 28, 31, up to 262. It means 262 is the last term of this sequence. Determine the number of terms in the sequence. So what are we finding here? We're finding n. So this is an arithmetic sequence. So we're going to use the arithmetic sequence formula. So Tn is equal to a plus n minus 1 d. Okay. Then what is our common difference is 3. 25 minus 2, that is 3. 28 minus 5, that is 3. 31 minus 28, that is 3. Then our a is 22. You can write that one down. A is equal to 22. D is equal to 3. What else do we need? N, that's what we're looking for. Then our Tn, which is the last term, is going to be 262. Okay. Alright, let's substitute. 262 is equal to 22 plus n minus 1 times 3. Okay. Then we can distribute this. So it becomes 262 is equal to 22 plus 3n minus 3. Right? And then 22 minus 3, that is 19. So 262 is equal to 3n plus 19. 22 minus 3, that is 19. Then here, this is actually our general term. This is our Tn, 3n plus 19, that's our general term. Right, so we're solving for n. Subtract 19 from both sides of the equation. We have 243 is equal to 3n. Then divide by 3 on both sides of the equation. N is equal to 81. So it means there are 81 terms. This term is term number 81, and therefore there are 81 terms in this sequence. Okay. Right, let's do B. We have to represent this arithmetic sequence using sigma notation. Right? Remember sigma notation will have our n is equal to 1 here, and our n here, we got that we have 81 terms. So we're going to put 81 there. Then what comes here? It is a general term, the Tn. Okay. Remember, we managed to get Tn from this in the previous question. We say that our Tn is equal to a, which is 22, plus n minus 1, d, which is 3. Then if we simplify this, get 22 plus 3n minus 3, then we've got 3n plus 19, isn't it? So 3n plus 19, that's our general term. Using sigma notation, this sequence is like this. And then we have our 3n plus 19 there. And then C. I'm going to show you two methods of dealing with this. If the pattern continues, determine the smallest number of terms that must be added to the sequence above so that the sum of all the terms will be more than 15,000. So now, how many terms must we add to this? How many terms must we add to this so that the sum of all the terms will be 15,000? Okay, so now we're going to use Sn. So we'll get the number of terms, the number of all the terms that must be added to get a number more than 15,000. That's the first method. Okay, and then I'll show you the second method. All right, so we have Sn is equal to n over 2, then 2a plus n minus 1 d. All right, we know our a is 22, our d is 3, and then we're looking for n, and then now the sum of these terms must be just greater than 15,000. Okay, so let me use the equal sign for now. So we're saying this should be just greater than 15,000. So it's going to be our n, that's what we're looking for, over 2, then 2 times 22, that is 2 times a, plus n minus 1, then times 3. And then this should be greater than 15,000. N over 2, let's simplify what is in the square brackets. You have 44 plus 3n minus 3, then greater than 15,000. Okay, you can even start by simplifying what is in the square bracket. So you have n over 2, and then 3n plus 41, greater than 15,000. Okay, let's distribute n over 2. What do we have? We have 3n squared over 2, then plus 41n over 2, greater than 15,000. Okay, now we can multiply everything by 2. What do we get? 3n squared plus 41n greater than 30,000. Alright, let's write this in standard form. 3n squared plus 41n minus 30,000 greater than 0. Okay, let's find n here. We're going to use the quadratic formula. So n is equal to negative 41 plus or minus the square root of 41 squared minus 4a, then negative 30,000, that is 4ac, all this over 2a, so it's 2 times 3. Okay, so we get that n is equal to negative 107,1, or n is equal to 93,45. Right now, what do? We discard this. N cannot be negative, even n cannot be a decimal here. But so what's the answer? Is it going to be 93 or 94? Right, it says, if the pattern continues, determine the smallest number of terms that must be added to the sequence above so that the sum of all the terms will be more than 15,000. So it means we have to add 94 terms. 94 terms will be the smallest number of terms that will give us just above 15,000. If it is 93 terms, it will be less than 15,000. So therefore, n is equal to 94. Right. But again, let's answer the question. It says, if the pattern continues, determine the smallest number of terms that must be added to the sequence. We are just adding to this. So it means we have to remove these 81 terms. Remember in question 5a, we found the number of terms. We say this is term number 81. So we have to remove these ones to get the number of terms that must be added to this sequence. So therefore, n should be 94 minus 81, which is 13 terms. So on top of this, 13 more terms must be added to this sequence to get just more than 15,000. Right, option B. Right, we can find the sum of these 81 terms and then remove this sum from 15,000. And then after that, we get the number of those terms. Okay, remember we say this is term number 81. This is term number 81. Right, let's find the sum of these 81 terms. So Sn is equal to n over 2a plus n minus 1 d. Right, the sum of 81 terms. So it's 81 over 2, then 2 plus 22 plus 81 minus 1 times 3. Right, we can put this whole thing in the bracket, and then what we get, the sum of the first 81 terms is 11,502. Right, so how many terms must we add to these 81 terms to get just more than 15,000? So we need to get the difference between 15,000 and 11,502. So we have 15,000 minus 11,502, which is 3,498. So now we're adding from which term? We're adding from term number 82. So term number 82 becomes like our first term, which is 265. This becomes our A. Right? The difference will be the same, which is 3. and then we just find our n. Our sum is 3,498. Sn is equal to, we have the formula already, n over 2, and then 2 times our a, starting from this term, is 265, and then plus n minus 1, the difference is still 3, okay, should be greater than 3,498, okay, right, and then let's simplify this, n over 2, then 530 plus 3n minus 3, greater than 3,498. So we can simplify this, n over 2, 3n plus 527, greater than 3,498. Let's multiply by 2 on both sides of the equation. Okay, we'll get n, then 3n plus 527 is equal to 6,996, right? Then we can write this in standard form, 3n squared plus 527n is equal to 6,996. Okay, right, standard form, 3n squared plus 527n minus 6,996. No, I've been using equal sign, still okay. Let's use equal sign. Just interpret the answer at the end. Right, 6,000, 0. Let's go to 0 here. Now we can use our quadratic formula. N is equal to negative 527 plus or minus the square root of 527 squared minus 4, 3, negative 6,996, all this over 2 times 3. Okay, you can use your calculator. You get n is equal to 12,39, or n is equal to negative 188,07. So we discard this, and then we remain with this. Now, how many terms must we add to get just above 15,000? How many more terms should we add? It should be 13. So n is equal to 13. See that we're getting the same answer.